Now, after medians, there's another important and beautiful concept called altitude. What does altitude mean, guys? What does altitude in general mean?
Height.
Altitude is the line segment drawn from a figure, a vertex to any point in the triangle, on the base of the triangle.
Good, good. Anyone with any other definitions? Think. Give it a try, I don't want you guys to be right. I don't care if you're right or wrong. Give it a try.
Sir, is it a bisector?
Okay.
I'm just guessing because on the diagram there's 90 degrees.
I think it's the it's the perpendicular line from the vertex to the opposite vertex.
Good. Now guys, very logically, if we've come across our everyday scenarios, when you visited a doctor or at home when you want to check your height, do you stand in a slanting position or do you stand straight? You stand straight, right? Now, what is altitude? Altitude is simply the height of the triangle. How do we get the altitude? Now, I have a triangle A, B and C. Can I say that if I start from A and draw a slant line and name it D, can I say that AD is the altitude?
No.
Right. Why? Because it logically doesn't make sense. Altitude, whenever we call it altitude, it's a straight line. We are asked to stand straight. Correct? Because if we slant or if we tilt, that is not going to give us the exact height. So similarly, in order to be exactly straight, what is the condition? You have to be at a right angle. You agree with me? That's 90 degrees. Is everyone following? That means it has to be a straight line. You guys agree with me? Which should form an angle of 90 degrees. Now when you're standing straight, we can say that yes, you are 5 feet tall, you are 5.5 feet tall, etc., etc. Now this, let me name it AE, becomes the altitude or the height. Are you guys now clear with this? Yes. In this diagram, he says that PS is the altitude. Why aren't all these other lines, all the dotted lines altitudes? Because they're not straight. But PS is straight, right? Exactly 90 degrees. Clear? Perfect. Now, if you're still not comfortable with this, let's look at it this way. There is a triangle. Let me extend the base. Let me draw this. If I do not want to look inside the triangle, if I want to look outside, remember the height should always be straight exactly. So can I say that this is the height of the triangle? Can I say that this is the height of the triangle? So similarly, this should be the height of the triangle. Can this be the height of the triangle, guys? Let me mark it DE. Can DE be the height of the triangle? Can it be the altitude?
No.
Oh, why? Because it has to be straight. Only then do we get the exact height of the altitude. Are we now clear? Perfect. So similarly, yes, because a triangle had 3 medians, a triangle also has 3 altitudes, right? One from the vertex A to the opposite side BC, one from the vertex B to the opposite side AC. Remember this 90 degrees that I'm putting? This was not there in medians because the idea of the median was to find a midpoint that that may or may not be at a 90 degree angle. But when I'm talking about altitudes specifically, I need the 90 degrees because the condition is that it has to be straight. It has to be measured exactly vertically, right? So how many altitudes have we got over here? 3 altitudes. That means if we had 3 medians, we also have 3 altitudes. Now, the concurrence or the point of intersection of the 3 medians was called the, what was it called, guys? It was called the centroid. So similarly, the point of intersection of the three altitudes is called the orthocenter. It is represented by H and called orthocenter. Are we clear with this?
Yes.
Are we clear with this concept?
Yes, sir.
Now, guys, if you remember in medians, I said that the centroid, irrespective of the triangle, whether it's an acute angle, right angle, or an obtuse angle triangle, it always lies in the center. Sorry, it always lies inside the triangle, was my statement. Now, can I say the same thing when I'm talking about altitudes, guys? Think. Yes or no? Can I say the same thing when I'm talking about altitudes?
No, sir.
No, sir.
Okay. Can you tell me why?
So because just now you said we can extend the lines and then we can check the height or altitude.
That was just to give you an example, but if I have to look at three triangles, acute, obtuse, and right angle, and if I draw the heights, can I say that always, that the orthocenter is always going to lie exactly inside the triangle, somewhere inside the triangle?
No, sir.
Let
No, sir.
us prove it. Let us see how we can understand that with the help of a very simple diagram. Acute is clear for you. In an acute angle triangle, the orthocenter lies inside the triangle. You guys agree with me? We just drew it. Let us look at a right angle triangle. Correct? This is 90 degrees. I have A, B, and C. From the vertex A, if I have to draw a perpendicular on the line BC, isn't AB itself the perpendicular, guys? So
Yes.
AB altitude, you guys agree with me? If I have
Yes.
to draw it from the vertex C, alright? If I draw a line, this is again 90 degrees, so BC is also the altitude. You guys agree with me? Yes or no?
Yes, sir.
Which is the last vertex that is left? B, right? If from B I have to draw another line opposite, on the opposite line, and mark it 90 degrees and say I mark it D. BD is also the altitude. You guys
Yes.
agree with me? Now, what is the point of intersection of these three altitudes? We have three altitudes. What is the point of intersection? Isn't it B, the vertex B? Can't you see that they are intersecting at the point B?
Yes.
1 second. Do you see that these three altitudes, AB, BC, and BD, they are intersecting at the point B? Does this lie inside the triangle? No, it lies exactly at or on the vertex of the triangle. So what can we say? When I'm talking about a right angle triangle, I can say that the orthocenter lies at the vertex which is making the 90-degree angle. Are we clear with this? Did you understand? Yes. Did I write some long 5-page proofs? No, I just drew and tried explaining it to you. Is it logical? Is it going into your head, guys?
Yes,
now,
sir.
I am not going to take obtuse. I'm going to leave that for you guys. And I want you guys to tell me either by the end of the class or in the next class whether if the orthocenter for an obtuse angle triangle lies inside the triangle, whether it lies at the vertex or where it lies. That is one question I am leaving to you. I discussed acute, I discussed right. If I'm talking about obtuse, this is what I am leaving to you guys. I want you guys to tell me the answer to this. This is what we just discussed. Orthocenter, the point of concurrence of the altitudes of a triangle is called the orthocenter. We have three altitudes which meet at a common point called H. I mean to say the orthocenter is labeled as H. Are we clear with this, guys? Is everyone clear with the concept of median, concept of altitude?
Sir, I didn't understand the difference between a centroid and an orthocenter.
The centroid is the point of intersection of the three medians. The orthocenter is the point of intersection of the three altitudes or the heights. That's the fundamental and the most basic difference. Are you now clear with it, Priscilla? I've repeated it a couple of times already while I was explaining this. Is it clear, Priscilla? Chalo. Let's look at this slide before we move on to our next concept. It says properties of altitudes and orthocenter. Now what's he trying to tell us? He is telling us, let us look at the properties of altitudes. The altitudes of an equilateral triangle are equal. Remember when we discussed medians in an equilateral triangle, we said all of them are equal. Similarly, because all the three sides of an equilateral triangle and all the three angles are equal, the altitudes of an equilateral triangle are also equal. You guys agree with me? Yes or no? Analogously, same logic on the same lines. Is this clear? Jaldi put in a yes or no. The second property, we are clear with the first one. The second property says that the altitude bisects the base of an equilateral triangle. And the third one says that the altitudes drawn on equal sides of an isosceles triangle are equal. So what's an isosceles triangle? I have three sides, out of which two sides are equal, and the third one is the unequal side. The altitude drawn on equal sides, that means from here to here and from here to here. So these are 90 degrees and these are 90 degrees. Are equal. How are they equal? Because guys, if the two sides, that is AB and AC, are equal, remember two angles were also equal in isosceles. Do you remember our previous session and even the session on lines and angles where we discussed this? On the same lines, because the two sides are equal, because the two angles are equal, the altitudes that are drawn on the equal sides of an isosceles triangle would then be equal. Similarly, the altitude bisects the base of an equilateral triangle. Why? Because all the three sides are equal. If I draw the three altitudes, they are going to bisect. What does bisect means? Bi means to, sect is separation. Separates the line or the side in exactly two equal parts. That is called bisection. Are these three properties clear to you guys? Are you able to imagine it when I'm putting it down in a triangle? Okay. Properties of orthocenter. Now these are again interesting. The orthocenter of an acute angle triangle lies in the interior of the triangle. Yes, we discussed, we looked at it, we proved it, we closed it. The orthocenter of the right angle triangle is at the vertex containing the right angle. You remember, we got the orthocenter at the point B. Chalo, perfect, we proved this too. Now, I asked a question, he's given away the answer, but he hasn't given away the proof yet. Remember, I proved it for acute angle, I proved it for a right angle, but he hasn't proved it, he hasn't proven it, or he hasn't given us the proof for the third property of his, that is the orthocenter of an obtuse angle triangle lies in the exterior. Fine, this answers a part of my question. So as to where it lies outside the triangle. Perfect. Why does it lie outside? That is what I need to focus on. It lies outside is what you guys will be taught or what you guys have come across. Let me discuss it before I move to the next concept. Who can tell me why it lies outside? Anyone? Who can tell me why the orthocenter of an obtuse angle triangle lies outside? You can unmute and speak. Go ahead. Anyone? I want you guys to give it a try. Arna, Bhavya, Priscilla, Saya, Gunmana. If you don't know, tell me that you don't know. But give it a try. Nothing wrong.
Sir, can you repeat the question?
I don't know.
The third property says that the orthocenter of an obtuse angle triangle lies in the exterior of the triangle. That means it lies outside. Why? How? That is my question. We are not here to look up the property. We need to understand the why behind it. That's what I'm asking.
Sir, can I try?
Yeah, go ahead. That's what I want. I want you guys to try. Go ahead.
Sir, maybe the altitude it joins outside the obtuse angle triangle.
Correct, but why does it happen? That is what he's saying. The three altitudes, they are going to meet outside. That is where we are going to find the orthocenter. But why? Why are they joining outside? Chalo.